Let's now look at the issue of enhanced commonality between the platforms. Before we show how the new Installation Manager works with WASZOS, let's first quickly show how installation has been handled up to this point. We start by drawing a vertical line and labeling the left side Acquire and Update, and the right side labeled Construct and Run. Those are the two main categories of activities: acquiring and installing the software from IBM, and applying updates to that codebase as IBM makes updates available, and constructing the server runtime and operating that runtime. The SBBO HFS dataset is the heart of this, prior to V8 and with V8 as well. That's the Unix file system that holds the WASZOS product code. That's typically mounted as something like /user/lpp/zwebsphere-v7r0, or with version 8, v8r0. The product code was acquired from IBM in an SMPE format, and SMPE was used to install the product and maintain it. The SMPE managed copy of this file system was then copied out of what was known as the service zone and mounted, again usually at the default user LPP zwebsphere v7r0 or whatever. Once that was accomplished, the construct and run phase could begin. Here's where the planning spreadsheet and the WCT came into play. Those tools were used to create the customized job which, when run, would construct the runtime, which included configuration file systems, JCL, start procedures, and SAF profiles. Here's one of our key messages. In WASZOS version 8, the SBBO HFS file system dataset remains central to the construct and run process. New and updated code is inside the SBBO HFS file system dataset, but it's essentially the same basic concept as before. And in WASZOS version 8, everything on the right side of this chart remains essentially the same. The WCT will be updated to support version 8, as will the spreadsheet, but the approach and the steps taken will remain the same. The new Installation Manager function of WASZOS will affect the left side of this chart. Now we're ready to take a look at what that means to you. IBM Installation Manager is a software installation and management tool first introduced in 2006. To date, it has been adopted as the installation management tool for over 120 IBM products. Imagine Installation Manager as a tool or utility on the ZOS system. How it gets onto your ZOS system is a separate discussion. It's a relatively simple installation process, and once installed, it's invoked and managed from the command line. On other platforms, it has a graphical interface. On ZOS, we don't have the benefit of that, so we go with the command line interface. To install a piece of software, WASZOS version 8 for example, you tell the Installation Manager to get that software from what's called a repository. Here we have to ask you to take that on faith and wait until the next chart to learn what a repository is and where it may reside. For now, consider it a store of packaged product binaries that the Installation Manager draws from to do its product installation. In the animation, we're showing a hypothetical product, ABC, being drawn from the repository and installed at location /user/lpp/abc. Here's a key point. The Installation Manager keeps track of what it has installed, what level of code it has installed, and what prereq and co-req relationships exist for that code. Now imagine we use Installation Manager to get WASZOS version 8. It pulls the product from the repository, updates its installed software information, and installs the managed copy of the software at the location you name, in this example /service/WASV8. In this example, we're showing how Installation Manager has installed and is managing a service copy of the code. That service copy is then copied out to the more typical mount point of /user/lpp/zwebsphere/v8r0. And once again, we have the SBBO HFS file system dataset, which is the starting point for the construct and run phase we said was the same in version 8 as it was in version 7. Now let's look at how you may incorporate SMPE into this process, if you wish. Some may wish to bypass SMPE for various reasons. If so, then going forward, it's possible to install and manage WASZOS without having to know and master SMPE. But suppose you want SMPE as part of this process. How does it incorporate? In essence, it becomes the manager of the Installation Manager repository. We bring Installation Manager back onto the chart just as we showed it on the previous chart. We bring SMPE onto the chart. SMPE is then used to install and manage binary copies of the Installation Manager repository as downloaded from IBM. The WASZOS version 8 code will be packaged in an Installation Manager repository, and, if you choose, packaged again as an SMPE managed FMID. Updates to the WASZOS version 8 code may be managed by SMPE and added to the Installation Manager repository. And the same holds true for feature packs to the WASZOS version 8 product. With SMPE managing the Installation Manager repository with the WASZOS version 8 code and any updates and feature packs, you now point your copy of Installation Manager at the managed repository. The SBBO HFS file system is constructed at the level you choose and copied out just as before. This is what provides you with software accounting, auditing, and control at the SMPE level if you choose. The alternative to this is to point your copy of Installation Manager at a URL hosted by IBM, where IBM maintains the WASZOS repository. And from that point, the process is the same. You specify the level you want, Installation Manager makes contact with the repository and pulls all the necessary binaries, and builds the installation file system, the SBBO HFS file system dataset in the case of WASZOS version 8. Once again, we're back to the heart of the construct and run element of this, the SBBO HFS file system. From there, the spreadsheet, WCT, customized job process is the same as before. The first topic is a new feature called High Performance Extensible Logging, or HPEL for short. This is a new binary format logging mechanism that helps lower the general overhead of logging, as well as provide a common logging format across all platforms. The HPEL function is optional. You may enable it on a server-by-server basis. Prior to version 8, the logging that was done on the distributed platforms was done to the file system. And a common method for reviewing the logs is to use Telnet and Unix tools. On WASZOS, we saw logging being done to the JES spool, with the controller region and the servant region being logged in separate held spool files. And if additional servant regions were started, each would have its own held spool location for output. WAS administrators use TN3270 to review the held log output for WASZOS. This may be what you wish to use in the future, so please understand the new logging feature we're about to discuss is optional, and it's configurable on a server-by-server basis. In version 8, we have a new optional method for logging that is common across all platforms. It also has the benefit of being more efficient. Output is written to the file system in all cases, but rather than a human-readable format, which has a lot of white spaces and is very inefficient to write, it's written out in a binary format. WAS administrators wishing to review the logs use a simple offload utility to copy the binary format out to a readable ASCII format. The format of the logs is now consistent across all platforms. To WAS administrators who manage distributed and ZOS platforms, the WAS is WAS message is now even more applicable. One of our goals is to enhance the leveraging of existing WAS skills across platforms. People skills are some of our most valuable assets. It makes sense to leverage them as efficiently as possible. We've already seen how the commonality of open standard specification support across platforms affords leveraging of Java developer skills across platforms. Now, with an increasingly common set of administrative interfaces, we see the theme broadening to that set of people skills as well.